Alright everybody, in today's video I'm going to be going over relays, their basics, and just a quick kind of overview of them. First of all, what are they? A relay is a switch that is controlled by an electromagnet. We've been messing with these kinds of switches that you yourself or a person has to physically switch, right? To go from one circuit to another, break a circuit. Well, with a relay, we can have a circuit control a switch to allow another circuit to come on or go off. So I have two relays here that are slightly different, but very similar. This is just the relay by itself, 5 pins. And this is another brand, but this is how you would find it on Amazon and mostly use them. This right here is a relay module, and with these pins it can easily be put into a breadboard or used with a microcontroller. And it has one extra feature that we're about to go over. This relay itself physically has 5 pins, but the module has 6. We have 3 over here and 3 over here. And that 6th one is really cool, and we're going to go over that here in a second. But first of all, what am I looking at here, right? What are these 5 pins? Well, here is a diagram of our relay, basically. So what this is, I mapped it out here to equal the same pin setup. 3 right here, 1, 2, 3, and then your 2 up here, 1, 2. So we have a coil that goes across. Where is? I'll just use this. We have a coil here that goes across these pins, and then we have a switch here that here's our common side, and when this coil is not excited, then the switch will be here. This is known as normally closed. Right now it does not have power applied because it's not hooked up, right? So it's in its normally closed state. So right now, if I were to measure continuity, I should get it from here to here, no ohms. The switch is closed right here. But if I were to measure from here to here, it'd be an open. It's not connected. But when power is applied across the coil, it becomes excited and will move the switch from this state to this state. And then this circuit can be whatever you want it to be over here. So then it will close over here, and this circuit between here and here will become open. Okay, let's say, hey, I don't know. How do I know which one's my coil? There's no labels. There's nothing. Well, if you look up the data sheet for this one, you'll see that the coil resistance is 70 ohms. And you want to make sure you're looking for your right one. So we're going to measure ohms here. And without power, right, we're safe to measure wherever we want. I can pick here and here. I know that this is not it. Okay, that's measuring open. I know that my coil is here between this pin and this pin. And look at that, 70 ohms. And it's pretty close. On the data sheet, it gives us 10% tolerance. So really anywhere between, 63 and 77 ohms means that we are within tolerance. So this is our coil right here. As mentioned before, our switch right now with no power, the coil is not energized. So the switch will be in its normally closed state. So if I were to measure my ohms from here to here, sorry, it's hard to gain, short, like it's closed, no ohms, no resistance, right? Perfect. So that's how I know that's the normally closed. And if I were to move to here, that's our open. So everything's lining up as expected. Cool. Another thing here, this is 5 volts. This right here, this rating. So what this is this is our nominal voltage. This is more or less what it will take to excite our coil. And so 5 volts is pretty common. This one and this one that I have are both 5 volts. You can see it right here in the name of this one, 05 VDC. Other common values will be 6, 9, 12, 18. You get it at 24, 48. And then, with each one of that will change the coil's resistance. So they're not all 70. Refer to the data sheet for your relay. These are different brands. The only difference between these two that I am possessing right here is this one is 7 amps and this one is 10 amps. And for this number here, I believe this is the maximum switching voltage or like contact rating. So everything else lines up the same rating wise. Okay, so enough with this one, the 5-pin. Let's move on to this one. This one, as you can see from the bottom of it, also has 5 pins. Actually, here, let's bring this one back real quick. And so here I have my 1, 2, 3, 4, 5. And right here I have my 1, 2, 3, 4, and 5. So, oh, there goes that one. Okay. So if I were to hold it like this is all the same. I can, if I wanted to, measure my resistance across this coil, 70 ohms. This should be closed, so no ohms. Cool, there we go. So the difference between these two is this one will have some additional circuitry on the board. And then right here, this pin, the S pin. You can call it switch, you can call it source. That's what this pin is. And you can see here, I've labeled what's on the board. We got a diode right here, our diode. What this diode is it protects the relay driver circuits. We have our transistor right here, and our LED and our current limiting resistor. Right here is our LED, and we have a surface mount resistor right here. And so what all this does is, if you look at the circuitry here, this is our switch, right? Our common, our normally closed, normally open. So if we look at our old one, this right here, our common, normally closed, normally open. And then we have our coil, right? These two pins. So this coil, even if you have your 5 volts across here, the circuit will not be complete. It cannot be completed. This coil still will not be excited if you have 5 volts across here until you give this supply some energy. And when you do, this transistor will then allow current to flow through it, which then will allow this circuit to be complete. Then the relay can switch. So, let me try to bring this full circle. Instead of this physical switch, we can have this relay switch based on a signal. Now, the best practical example I can give you that I relate to is the thermostat in my house. So basically, if you ever walk by it and you hear like a click, that's this. That's your coil getting excited, and then you are hearing the switch physically being drawn to it due to the electromagnet that's inside of this. So you can say to this relay, the AC should not be on until whatever temperature is met, right? Once that temperature is met, then the circuit inside of your thermostat will turn on, send a little signal, allowing this coil to become excited, which will then allow your relay to turn on, and then you are essentially controlling another circuit, which will be your AC. Does that make sense? So over here, you have, a circuit hooked up. Nothing's being triggered. As soon as, where's our S? S right here, our source. As soon as this gets power sent to this pin, then you are allowing, instead of this circuit to be completed, this circuit to be completed between these two to turn on and run your AC. Isn't that crazy? That's awesome, right? That we can have such a small little power go across here, opening this up, exciting our coil, and then turning on our AC unit for our house. Now, they are more complex than that, but that's like the essentials. That's the basics of it. And so, you don't have to go up every time to your wall and physically, it's hot in here. Click, flip a switch to keep it cool, We rely on this throughout the day to keep our house cool for our pets while we're away. All right. So let's go ahead and see this in action. I'm gonna hook this up. I am not gonna hook this one up to the breadboard because it's not breadboard friendly. It doesn't just go in there. That's kind of why they have these. Just for your reference, these bottom ones, if you can see that, are labeled from left to right is source. The middle pin is our positive, and the rightmost pin is our negative. Again, this source is for our coil. So this will be 5 volts. And then up here we have our common for our circuit. And then this will go out to our Oh no, I had that right. This will go out to our normally open circuit. It says NO right here. And on this side, NC. So we can have our normally closed circuit go out to here. So let's go ahead and move on over to the breadboard and hook this guy up. All right, so now we're at the physical breadboard part. Let's go ahead and start hooking this up real quick. So you know this wire is just attached to my 5-volt rail. So I'm gonna have 5 volts. We're gonna explore some things, but just know that for now I have 5 volts coming into a push button. I'll explain that later. But then the 5 volts, right? This relay is rated for 5 volts to excite the coil. I have my 5 volts coming in right here, and then this one will be my ground, and then additionally I'll need my source. So for my source, that will be 3 volts. So it'll look like that. Okay, so I have my source, and then middle pin, positive, and then top pin will be my minus. 5 volts source. Then up here, I have my red wire. Oops, sorry. My red wire will go to my normally open. Yellow wire will go to normally closed. And then the blue is just my common. So should I put this in first? Okay. Then my supply, the 3 volts for now. Okay, so my common on my switch is just going to be powered with 3 volts for this one. I'm going to have my normally closed go to the green LED, and my normally open go to the red LED circuit. So these are my circuits. I have, oh, there goes my meter. I have a red LED circuit and a green LED circuit. So when the coil is not excited, the green LED will be illuminated. When it becomes excited and the relay clicks, then current will flow to this circuit. So these are the two that we'll be controlling. Sorry. Let's quit rambling and get going. All right, I think we understand this so far. Just gonna power it on and then we'll go from there. Off. Okay, let's hook it up. And now here we go. Oh, okay. There we go. Okay, sorry. I misplaced my push button here. So, here we go now. Right now, this also has an LED on it. That's why it's red, as you can see here. This is our red LED that you're seeing. This illuminates when the source is giving power. So if I were to remove the source, I would remove the LED. And when this is removed, this transistor will not allow current or this circuit to be completed. Therefore, the coil cannot be excited. So even if I were to push my button, nothing will happen. But once we tell our source, hey, let the relay switch. Okay, it's now powered on, and now I will be able to seal my 5 volt some power. And when I do that, we switch circuits. Now, the best way I think of this is like, again, the thermostat at home. So, it's not cold enough in the house. Okay. And imagine, like, every time you want the AC to come on, you had to go to the wall, flick a switch to make your AC come on. That'd be annoying, right? But with this, what we can do is say, okay, right now, it's cool enough in the house, but then after a certain limit, the microcontroller on the thermostat will be like, okay, I need to turn on now. So it will send a signal, and then that will turn on the relay. And that click in here that you hear is the electromagnetic turning on, and you hear that switch engaging or flipping sides because of the magnet. Next time you hear your thermostat kick on, listen for that click. That's the relay. So now if I were to remove this switch, that might make things make a little more sense, or click. So let me turn off my circuit. I'm going to remove my push button, bring my 5 volts over here, directly into the relay. And now my signal wire, I'm just going to disconnect it. So now no signal is being sent to the relay, right? Power on. Okay, so it's cool enough in the house. Our temperature is where we want it. Okay, after some time, okay, now it's 71 degrees in the house, and we have our thermostat set to 70. So, there's going to be that little computer inside your thermostat that will tell the AC, hey, I need to kick on. So let's go ahead and kick it on. I'm going to send a signal. And once that signal is fed to the relay, that switch will engage and our other circuit will come on. Okay, now it's been cool enough for a while, and we can now stop sending the signal, and our AC unit will turn off. Just like that. That's pretty cool, right? Hopefully you can see the potential with this thing. So what you can do now is we have two states, two circuits, right? You can also think of this as a binary, 0 or 1, off or on. And so this signal wire is coming from a circuit, right? You can have, instead of this LED, what if we were to replace this circuit with another relay, another module like this one, and this output go into be as like a signal input into another relay. So now when this relay comes on, it will kick on another relay, which that relay can control two circuits. So then we'll have this circuit, and then this one will be going as a source to our other relay that will have an output of 2. So then we'll have 3 outputs. And then, you can just use one of those relays as a source, and so on. So you can get into some really cool digital logic, ones and zeros, and do some really cool things with relays. So just one more time, I'm going to refer back to here, kind of recap what we learned. This transistor will not allow this relay to get excited, even if voltage is applied, unless a signal is sent through, then we will allow it. And we also learned how to find out what pins, here we go. What pins are what, right? There's no labeling on this thing. How do I know? Well, we checked it with the ohm meter. According to our data sheet, we're able to find which ones were the coil due to the coil resistance. And let's see, right here is your nominal voltage. Again, with the ohm, okay, we know these are a coil, so that leaves us with these 3 pins. You can take your ohm meter again and, okay, which one's short, which one's open. Your short one is going to be your normally closed, and then your open is going to be your normally open. So there we go. Hopefully this helped you guys out with relays. You can buy these ones, a bunch of them for cheap on Amazon. Buy these ones in bulk on Amazon. Just remember, these ones are not very breadboard friendly, if that matters to you. And yeah, go out there, have some fun with relays, and now you know what, why, how. Cool. Hope you enjoyed this one.